Pacific. A young man clawed at his eyes, full of visions he prostrate on the ground in his village. Told of a monstrosity called capitalism. Said the food they grew would be shipped from the country, and they barely get by. Well, someone else got the money. Said the government helped these people out with the army. Problems that were never big would inflate alarmingly fast. But the people walked past. He thrashed on the grass. Nobody paid attention except the few who had a laugh. No mind could imagine such a change of scenery. The culture was strong and intact like the greenery. But not for long. To the planet at last, man. Revolution made it happen really fast. They said, how can we find?
Hello, New York. My name is Robin Blumner. I'm the CEO of the Center for Inquiry and the Executive Director of the Richard Dawkins Foundation for Reason and Science. Thank you. Thank you. So these organizations merged about 2 years ago because we had the same mission, which was to promote reason, science, and humanism, the magic elixir of human progress. So the evidence-based community has sort of taken a sucker punch lately, wouldn't you say? News gathering, responsible journalism is fake news. We have expertise being denounced as partisan drivel. Facts are fake. Well, there's an antidote to that, and that is the Center for Inquiry and the Richard Dawkins Foundation. So I'd like to know from the audience, how many people here care about the separation of church and state? All right. And how many people here want to make sure that evolution is taught in science classrooms and not creationist drivel? How many people want to make sure that children are vaccinated entirely? All of them. And finally, how many think that it's about damn time that an open atheist was elected to political office? All right. Okay, you can stay. You can stay. So today, have a wonderful time. Tomorrow, think about joining the Center for Inquiry and the Richard Dawkins Foundation. You know, when the religious right wants to rally the troops, it gets millions of people responding. And we need a secular army. We need to be able to challenge the power of the religious right, and we need your help to do it. So have a great time tonight. Join us tomorrow. And now I'd like to introduce the producer of the evening, Travis Pangburn.
All right, how's it going, everybody? It's nice to see you all. What do you think of the space pants? Thank you. They kind of look like painter's pants, I'm sure, from back there. Sorry about that. Yeah, I'm so excited to be in New York again. I just had to come out and say thank you guys so much for supporting this event. Like, it's becoming popular to think. Yeah. A couple quick announcements. We will have a Q&A about an hour and 15 into the talk. We will do a book signing in the lobby. Brian and Richard will both be part of that. And what else? Okay, our next event that we have coming up, very controversial event. On November 17th, we're doing a conference here in New York City. You can find out more about that on our website at penguinphilosophy.com. Hope you guys come and check it out. We have a lot of great speakers. The topics are very controversial. The first topic of the evening is, has Me Too gone too far? So that kind of sets the stage for what kind of a conference it's going to be. So hope you guys join us for that. Again, penguinphilosophy.com. And then Matt Dillahunty. How many of you guys have heard of Matt Dillahunty? Nice. Well, those of you who don't know, check out Matt Dillahunty. He's going to be going head-to-head for the first time with Dinesh D'Souza on, yeah. Dinesh D'Souza sucks. No, on November 29th. And so come out to that. That's going to be at the Town Hall Theater here in New York City. It's going to be a lot of fun. I'm looking forward to that. You should check out the video of Matt Dillahunty and Jordan Peterson that we have on our YouTube channel. That's one of our highest trending videos, and that's going to give you a taste of what that event's going to be like, I think. And then also on December 6th, back at Town Hall Theater, we will have Steven Pinker and Matt Dillahunty having a conversation. So I hope you guys come out for that. Anyways, that's way more than enough from me. Please welcome to the stage Richard Dawkins and Brian Greene.
So it's a pleasure to be here tonight. Richard, welcome back to New York, and welcome everybody here to tonight's conversation. Just to sort of get things going, Richard, we spoke, I guess it was in 2014. We had a conversation, I think it was at 92nd Street Y. And I could be wrong, but I got the impression from that conversation that you were doing a lot of work, a lot of self-reflection to try to come to terms with your own religiosity.
No.
But that's exactly right. So you came out with a very strong position on that. But as time goes by, people get older. Sometimes their view shifts. So you can just give me a yes or no on this. Has anything changed in that regard since we last spoke?
Absolutely not, no. Can you hear me? I don't think you can you?
Yes, I think we...
Could somebody fix my...
we don't know each other that well, but, this is how you get to know the person that you're going to be conversing with. You can just get that right in there. Is that tight?
It's the second time it's come off.
I think that's good, right? Well, let's try to go with that and see how that goes.
Okay.
Good. So anyway, nothing's changed. Thank God. That's great. When I think about the big questions, I tend to organize them into origin of the universe, origin of life, and origin of mind. And I'm actually teaching a course with that theme at Columbia, and we read The Selfish Gene this term as part of that. I hadn't read it since I was in college, so it was spectacular to re-engage with the wonderful book that you gave the world. A question came up in the class.
All right.
And I would like to check with you to see if the answer I gave makes sense and aligns with your thinking. So the question a couple of kids asked was, look, we read this book and we get a very clear sense of evolution, the gene as the basic unit of heredity, but we're still left with the question, what is life and how did life get started? So my response to that, which some of them found quite unsatisfying, is that that's not as precise a question as you think, right? I mean, in some sense, trying to draw the line between animate and inanimate and trying to have a very precise definition ultimately amounts to words, right? It's a continuum from inanimate to animate, and once we have the molecular Darwinism in place, rolling forward, life just emerges in that continuum. So my question to you is that a reasonable way of describing it?
I think it is. I think that there's a too great a tendency in the human mind to try to draw lines and to try to, where there is a spectrum. I mean, sometimes there really is a line, but in other cases there isn't, and we should not insist that there has to be a line. Well, in the case of life, I suppose you could sort of see a kind of line when the first self-replicating entity came into existence, because that was the moment when natural selection, and hence Darwinian evolution, could start. You can't get natural selection unless you've got something equivalent to a gene. So the first gene, which would not have been DNA, by the way, but the first gene would be a kind of watershed event, I suppose. But I agree with you, we don't want to get too hung up on the questions of definition, like definition of life, as opposed to non-life,
right,
which demand a particular moment at which life came into existence.
And when you say first Gene, in that context, can I think of it as the first molecule that discovers this capacity for making copies of itself, period?
Yes, making copies of itself, and that would include making copies of errors in itself.
Right.
So that there has to be variety in the population of these replicating entities. The reason I say it wouldn't have been DNA is that DNA has been described as a high-tech replicator that requires a rather complicated infrastructure of biochemistry in order to do its replication. So people in the field agree that the first replicator would not have been DNA. It would have been something else that had the property of self-replication, probably much less efficient at it than DNA. And DNA would have been a late usurper of that role. It could have been RNA.
And do you think it was RNA?
I don't know. I mean, that's a current fashionable idea. And the reason it's fashionable is that, as you know, there's a kind of divide in biochemistry between the protein, which acts as enzyme, and the variety of enzymes, which is the key to everything that goes on in life. The fact that the three-dimensional form of a protein molecule, when it coils up into a sort of knot, which gives it its enzymatic properties, and that is determined by the one-dimensional sequence of amino acids, which in turn is determined by the one-dimensional sequence of DNA. So there's this double act between DNA and protein. DNA is not an enzyme, it's an excellent replicator. Protein is an excellent enzyme, but cannot replicate. RNA is kind of moderate at both. So if it started off with RNA, that could have done both the enzyme role, because RNA is a kind of rather bad enzyme,
right,
and a kind of rather bad replicator, but it can do both roles. And so the idea is then that DNA would have come in and usurped the replication role, and protein then came in and usurped the enzyme role.
So how big a molecule do you imagine this first replicator would be?
I suppose it would be quite small, the first one.
Right. I mean,
but I don't know. I mean, this is an active field of, well, I suppose research, but very speculative research.
Right. Because you'll see people making the argument that whatever molecule you put forward as the first one, if it has some degree of complexity associated with it, you can then ask yourself, what are the odds that that molecule will form? And when that number is necessarily quite small, some people see a tension with the naturalness of the process and the unlikelihood that it would happen. So how do you answer that?
Well, it is a field where there is no answer yet, and people are not confident of it. There are various problems with the so-called catch-22, that you can't get DNA without protein, and vice versa.
Right.
There are other problems with it. Some people have favored what they call a hypercycle, where there are various stages in a chain, and each stage gives rise to the next. So there's no one molecule is the key replicator. The entire hypercycle is the replicator. But it's not a field which has been solved. It's not a question which has been answered. It is still conceivable that the origin of life, the origin of self-replication, the origin of natural selection, was a stupendously improbable event.
Right.
And the corollary of that would be that there's no other life in the universe. I mean, or put it the other way, if you want to believe that there is only one life form in the universe, which you're entitled to do, then a corollary of that is that the origin of life on this planet must have been a fantastically improbable event, so much so that any theory we come up with has got to be a very implausible theory.
Right.
Because if it were plausible, there would be life all over the universe,
Yes.
which I suspect there probably is. I'm just saying that if you want to believe that life only arose once, then what you're looking for in a theory of the origin of life is not a plausible theory such as you could replicate in a chemistry lab.
So, I mean, so there is a lot of evidence that all life on Earth comes from a common single-celled ancestor.
Yes, the evidence for that is that the DNA code is all but universally the same in every living form that's ever been examined. And the odds of that coming about convergently is extremely low. So I think just about everybody is convinced that every single life form, at least those that have been looked at, descends from a common ancestor. It's because it's got the same machine code at its base.
Does that strike you as a puzzle or just something that we need to
No,
accept?
I don't think it's a puzzle. I mean, it could be that more than one life form arose originally.
And we just don't see them.
And we don't. And as Darwin said originally, one of them ate up all the others.
Right.
So that's a possibility. Paul Davies, your physics colleague, thinks it's worth looking to see if there are other life forms. They may be around on Earth but never been found. I liken that to the looking for your keys under the lamppost. And when somebody lost his keys, and so he's looking under the lamppost for the keys. And somebody else asks him, why are you looking under the lamppost? Is that where you lost your keys? No, but that's where the light is.
Right.
So if we're asking the question, is there life elsewhere in the universe? We can't go elsewhere in the universe yet. It's very difficult to. So let's look
But the
here.
universe can come to us, and some have suggested that maybe the origin, life in some form may have come here on a meteor or got pummeled off of Mars.
Well, that's not so implausible as it was once thought to be.
Yeah.
It's the theory of panspermia, invented by a Swedish biologist called Arrhenius about a century ago now. And it was espoused by Fred Hoyle, the astronomer, very distinguished astronomer, but he kind of went adrift a bit on evolution anyway. Directed panspermia is a more far-fetched idea, which was actually favored, I think, a bit tongue-in-cheek.
You mean that actually someone sent it here to seed life?
Francis Crick, the great co-discoverer of the structure of DNA, together with Leslie Orgel, suggested that our planet could have been deliberately seeded by an alien civilization. I think it was a joke. I mean, they sort of presented it as though it was a serious theory, but
right. So when you consider the rich spectrum of life on Earth that all say arose from this singular starting point, do you find that the range is sensible relative to the environment that life found itself trying to adapt to, or do you find it strange that we don't have beings with 9 eyes, or eyes that work under completely different principles, or I don't know, some being that would be sensitive to gravitational waves?
Yes. Now I'm very fascinated by that kind of question. And you can get a long way by looking around the animal kingdom and asking how many times different things have evolved. And you can work out how many times they've evolved, because you can work out what the tree of life actually is. You know which animals are close relations of which. So we know, for example, that there are, I think it's 9 different principles of eyes, different ways of doing the optics. And that eyes have evolved independently several dozen times. One estimate is more than 40 times.
Really?
So eyes actually evolve with great ease, with great frequency.
And they're all sensitive to the same part of the spectrum because of the sun?
Not exactly the same, but it's overlapping.
Right.
Insect eyes move towards the ultraviolet, for example. But it's nice to think that all the ways of making an eye that physicists have thought of have been thought of by evolution in rather interesting ways. I mean, the compound eye works in a totally different way from the camera eye, which is what we have. There are mollusks which have a reflector eye, a parabolic reflector.
You mean like a radio dish out there?
Yes,
really?
but optical.
Wow.
There are scallops that have that. And there are lots of different kinds of compound eye, lots of different kinds of camera eye. And they've evolved independently. Other things like, say, echolocation, navigating by sonar, by sound waves, that's evolved 4 times independently. In bats, whales, and 2 different families of birds, cave-dwelling birds, independently. So that's rather more reluctant to evolve, but nevertheless it has evolved more than once. Some things have evolved only once, and so you feel they're improbable things.
Right. So in trying to understand the likelihood or not of the emergence of life, and therefore to try to gain some insight into the question that you made reference to, whether we're alone or there's other life out there in the universe. Sometimes people write down this Drake equation, which every time I see it, I always feel like it's misrepresenting the situation, because it's not so much an equation describing the actual likelihood of the arising of life. It's more a way of encapsulating our ignorance of all variety of qualities of the universe that we really don't have any insight into. So any number that comes out of it is really just totally dependent on the ignorance that we have regarding the numbers that go into it. But be that as it may, when you think about that life may have just started once on this planet, does that diminish your expectation that the search for extraterrestrial life will be successful?
Well, we can't escape from the fact that it did arise on this planet. I mean,
so it's a sample size of 1, and what do you do with that?
I would love another one. I mean, because we just don't know, and I'm very intrigued by the question how much of what we know about this form of life had to be so because there's only one way for it to be. For example, does there have to be something like a gene? I think the answer is yes. Does it have to be...
I mean, just because you need something to propagate the information, right?
Does it have to be a one-dimensional array? Does it have to be digital?
Right.
I think it probably has to be digital.
Digital because otherwise errors would creep in too quickly.
Too much error, yes.
Right.
Does it have to be a one-dimensional string of data, which DNA is? And I don't think that's clear. I mean, I could imagine a 2-dimensional matrix,
right,
which could be read. Not 3-dimensional, because you can't get inside the 3-dimensional blob. So that's kind of question. Does there have to be sex? Would you expect to get eyes? I bet you'd get eyes, because eyes have happened so many times here.
But presumably if it was a star that emitted strongly in a completely different part of the spectrum,
then
maybe sensitivity or something of that sort.
Yes, exactly.
So, so it leads to the question that if you had your choice, in some sense, as to what we would find if we encountered life in another world, would you want it to be the same in order that you would have a unified theory of life in some sense? Or would you rather it be different so that now you just see this grand spectrum of possibility with us just being one of many?
I'd be delighted by either. I mean, if it were too similar, if for example you found life on Mars and it was DNA based and the DNA code was the same.
Right, then it's probably the same.
Then it's got to be contamination.
Right.
Because we know that...
So it would mean we're Martians. It could have come from there.
It could have come from there.
Right.
But we know that a lot of meteorites have come from Mars. So but if it were DNA but a different DNA code, that would be rivetingly exciting.
Right.
If it were not DNA but something like another polymer, gosh, it would be fascinating. Amazing. I think it would be the most exciting discovery ever, actually, to find something like that. I mean, we, as you say, we've got a sample of one. Life on this planet is uniform at the biochemical level. Even great big creatures like us, we do our biochemistry quite largely using tricks that were discovered by primordial bacteria, and many of them are in us, doing the same trick. We've simply commandeered them.
Yeah, no, it'd be hugely exciting. Almost exciting as string theory or something like that. Yeah.
We'll come on to that.
Yeah, but so as we enter an age when we can begin to actually tinker with the actual structure of life, say CRISPR-Cas9, Do you imagine that we'll be able to gain some insight into these questions in the laboratory, as opposed
I think, yes.
to...
I mean, whenever I meet a biochemist, I always ask them, can you imagine an alternative biochemistry? Could you construct an alternative biochemistry? Right. Or if you can't construct it, at least imagine it. Does it have to be carbon-based, for example? I think the answer to that is probably yes. Would you agree with that?
Well, I mean, carbon is certainly the natural go-to species if I didn't know anything about life and you gave me a list of criterion that you want to have a very active molecule, you want it to be able to bond with all sorts of other molecules in the environment, you want it to be a species that's commonplace so that it's not a rare species that we deal with. But there are other pretty active species too.
Well, silicon is mentioned
for
as an
example.
element which could possibly do the same job.
Right.
But I asked Harry Kroto, the famous organic chemist, and he's confident it'll be...
That it have to be carbon-based.
Yeah, it has to be carbon-based. But that leaves a lot of freedom, nevertheless. I mean, even within carbon, within organic chemistry, an enormous freedom to devise alternative biochemistries.
Right. Now, do you think that there will come a point when we just can create life from scratch in the laboratory? I mean, is that in our future?
Yes, I think so, yes. I mean, well, Craig Venter has already created...
Well, sort of.
Replica, I mean, just sort of reproduced the same thing. Yes, so
I mean, do you want to say what Craig has done just to...
Well, he has recreated a particular bacterium from scratch. But it is just one that already existed.
Right.
Well, if you can do that, then you could theoretically create one that doesn't exist already, and from that, I suppose you might even go on to multicellular life.
And so, does this? I mean, obviously, this is an exciting possibility. Does it scare you?
It excites me more than it scares me. I'm just fascinated by it and by the possibilities. So I do think we have to exercise a precautionary principle.
And how would you imagine doing that?
Do you know Sidney Brenner, the great molecular biologist?
Not personally, but yeah.
Keep the lid on your Petri dish well screwed down, he said.
But any criterion and restrictions you place in this country or in your country, right? I mean, this is not a worldwide type of...
No.
So...
But there have been attempts. I mean, there was a meeting of molecular biologists at one point to sort of devise a kind of moratorium list of things that you mustn't do, and I think it held for a while. I mean, I suppose a greater, more present worry would be if the techniques of creating or of varying microorganisms were to fall into the wrong hands. I mean, biological warfare has been experimented on by some of the great powers, and if the techniques fell into the hands of terrorists, especially if the terrorists, for religious reasons, want to die, and therefore don't care whether they destroy the world.
Right.
I think that's probably more of a worry than the kind of thing you were raising of creating life.
But the bottom line then, summary, if I'm hearing you correctly, is you would agree, presumably, with the statement that 100 years or 500 years from now, people will look back at this era and sort of smile at the mystery that we once thought was embedded in life, and it will just be another concoction of chemicals that happens to be able to carry out certain processes, and people will shrug as opposed to revere this entity that forms, at least on this planet.
I suppose if there's a lesson from history, that one can look back on earlier eras and feel that way, yes.
Well, I mean, at the end of the 19th century, there's a famous statement in physics that I'm sure you're familiar with. Lord Kelvin is usually credited with saying it. It's unclear that he actually did. that, all the laws of physics were worked out except, this or that constant of nature that needed to be evaluated to the 6th or 7th decimal place. And of course, that was before the discovery of special relativity, general relativity, quantum mechanics. So it's spectacularly wrong. So it's spectacularly short-sighted.
Yes.
But do you think it's possible that there is a discovery, a phase, a step on par, say, with quantum mechanics, which, for physicists is the revered step in our understanding of the natural world, that we're completely missing right now?
Yes, a different kind of precautionary principle. You've got to be precautionary about what you say and not fall into the Lord Kelvin error.
Right.
I think it was Lord Kelvin also said radio will turn out to be a hoax. And what else did he say?
I don't know if I know that one.
He said heavier than air flight is impossible.
Geez, you're really taking my hero and just cutting the legs out of it.
Well, no, he was a great physicist for his time, but he also gave Darwin some grief because
I opened a can of worms here. This is fantastic. Yeah, go ahead.
He gave Darwin some grief because he calculated that the sun was too young to have allowed time for evolution, and that's because he thought the sun was a fire burning fuel, and had no way of knowing that the sun is a nuclear reactor, and so Darwin was intimidated because physics was the senior science, and so in a way Kelvin kind of came a bit heavy on Darwin and said, well, physics proves evolution not possible. What Darwin should have said, well, the evidence for evolution is overwhelming, so your physics must be wrong.
Touche. So, if we go from life to intelligence, conscious self-awareness, there's a similar collection of puzzles, obviously different in detail, but revered by many through the centuries. And in the modern era, David Chalmers is famous, down at NYU now, famous for articulating the so-called hard problem of consciousness, right? The problem that if matter is all there is, matter and fields, and if electrons and quarks and the entities that they build up, protons and neutrons, if they have no inner world, if the lights aren't on inside an electron, if it has no inner sensation, if a third-person account precisely describes what's going on with an electron, there's nothing else. How could it possibly be that when these particles swirl together, they somehow generate an inner sensation, a quality that simply is absent at the level of the fundamental ingredients? So, he was dividing up the problems in neuroscience and brain science into those that have to do with the mechanism, the function of the brain, which ultimately can be difficult to work out, but it's clear what to do to figure out, what's going on when, my arm goes up and down, what sort of brain signals are making that happen. But he considered a qualitatively different question to be the one that I was referring to, namely, how can the lights turn on? Do you see that distinction?
Well, I always confess myself baffled by it. I do see it as a profoundly difficult problem. I am committed to the view that there is nothing there other than physics. There's nothing there other than, as you say, atoms and electrons.
And I agree with you. But where does that sensibility come from? Is it based on evidence?
I suppose it comes from the feeling that, as an evolutionist, we start with physics, and then we get chemistry, and we get a process, Darwinian natural selection, which gradually builds up nervous systems step by step. They get more and more complicated. I can't see any other way but that.
Could that be limited mental acuity and creative powers?
I think it has to be that, but I'm more curious to know what you think. But as a physicist,
I thought I was asking the question. No, it's good. No, we actually we're going to go back and forth on questions. And I agree. I can't imagine that there's something beyond Schrodinger's equation of quantum mechanics and the interactions of the particles that's going on inside this physical structure inside of my head. But I still feel deeply puzzled by how it is that I can sit here and have this inner world. Everything that we do in physics, and think science more generally, is so focused on the third person account. We can look out, objectively see data in the world, find the patterns in that data, articulate the patterns in mathematical equations, use the mathematical equations to predict what's going to happen next, or the probability of what's going to happen next in a quantum mechanical framing. And that's what we do. We never have this turn inward to try to have that same kind of rigor and description of what's happening inside of our heads. Now, what David Chalmers says is, he says that's not just a small issue, that's a huge issue, if I understand what he's saying correctly. He's saying we perhaps are missing a side of the story which would endow perhaps electrons and quarks and other particles with a degree of proto-consciousness. Maybe there's something beyond mass and charge and spin. Maybe there's something there, and only by taking into account that quality that we've been missing can a lot of those particles yield the sensations that we're all having right now.
Starts to sound dangerously like Deepak Chopra if you're not careful.
Well, I'll tell David that you said that.
I mean, I'm also intrigued by philosophers' thought experiments where they say things like, imagine that you could make an exact copy of every single atom of you, and there are two of you standing side by side. Which one is you?
Both. I have no doubt that they're both.
Yes, but then presumably you would have the same consciousness.
Yeah, same memories.
But then they would
diverge.
Start to drift. They would start to drift apart.
Yeah, so there'd be two of me.
Yes.
You know, I'm not sure that would be such a good thing for the world. But that's on that question. I feel secure in saying that. Obviously, if one day we can do this, it'll be the best way to find out. But part of that sensibility for me, and I'm wondering if it's the same for you, I don't think that consciousness has to take place inside a particular physical structure, you know, the human brain or the brain of any other animal. You know, I think that once you replicate the function, you've replicated the experience. Do you?
Yeah, and I mean, I think if you could somehow upload everything into a computer, that also would have to have our consciousness. But these, I agree with David Chalmers. It is the hard problem, and it's certainly too hard for me. But I wouldn't take the leap to say that. Therefore, I know something like, you know, every atom must have a little smidgen of consciousness, or something like that.
No, I don't think he took that step without a great deal of difficulty. With basically banging into every possible avenue that he pursued for many years, and it almost felt like there was no other place to turn. And having not gone through the journey that he and others who spend their lives trying to figure out consciousness have gone through, it's hard to know whether I, or perhaps even you, would feel the same way after hitting wall after wall after wall. But it's certainly the case that even on planet Earth, where we discuss that life may have had a unique origin, the arising of intelligence and conscious self-awareness, that also seems to have been a miraculously improbable event that allowed that to happen.
Yes.
Right? I mean, what if the meteor hadn't wiped out the dinosaurs? I mean, would we all be sitting here and we'd all be dinosaurs and having this conversation, or would we never have gotten to that place?
I suspect not. I mean, I think that there would be lots of dinosaurs around, but it's.
But we would.
I think it's a major step. We were talking about whether the origin of life was a big step, and perhaps it was. So we don't. And I said that was a corollary of whether we think there's life elsewhere. So there might be swarms all over the universe of bacterial type life. But if we ever discovered life elsewhere, it would have to be by radio waves coming in, and that means it would have to be technologically sophisticated life, and that means it would have to have overcome another barrier, so that the barrier from bacterial level life, maybe there are several intermediate ones, and then up to the kind of life that's capable of producing radio waves that we can detect.
Right. So long if it's far enough away. I mean, if it's near enough by, in principle, we could.
If it's near enough by, yes. But
Right.
I'm suspecting that's probably not. I suspect that if we ever do discover extraterrestrial life, it will be by SETI. And in that case, we have the question: do we have a second barrier, or maybe a third or a fourth barrier,
Right.
and to produce the sort of intelligence? We don't have to get into consciousness. I mean, it could be unconscious, but
If it could talk to us, that would be good enough.
But
Right.
if it can produce radio signals,
Right.
then that's a much more mundane question than the question of whether the light, as you say, the consciousness light is turned on.
So do you think if we discovered life that's not intelligent, would it make much of a difference ultimately to life here? I mean, it would be an exciting moment and so on, but would it then, we have what? It used to be that you had a week news cycle, a 24-hour news cycle. Now it's like every 10 minutes. So would this be like from 10:30 to 10:34, bacteria found on Mars, and then by 11 o'clock Trump would do something else and everyone would forget about it?
I like to think that it would change the way we think about our own life, but maybe it wouldn't. I think it really would if we were contacted by intelligent life forms elsewhere, especially as if it was intelligent enough to get its signals here, it would have to be a lot higher level than us. And so we would have a lot more to learn from them than they would learn from us. And so that really ought to shake our confidence and shake our...
Now, if it was far away, it would be a pretty slow conversation.
You couldn't have a conversation, no, that's right. But you could listen to them.
Right. So let's say we did have this conversation going. Let's say we get over the barrier somehow, we learn how to communicate with each other, and fancifully, let's imagine that the conversation happens more quickly than
500-year interval between.
So let's put all that to the side for just a second, which is certainly a technical detail. Could you imagine that the logic by which this intelligent extraterrestrial society lived and thought and worked and created would be fundamentally different from the logic here?
I love that question. I mean,
You've heard this question before? I mean,
well,
is this frequently asked to you? I feel so hackneyed. I thought it was a good question.
That's why I say I love it. I mean, clearly they would have Pythagoras' theorem. They would have numbers. They'd have geometry. They'd have. But I'm like you. I'm curious to know whether they'd have a completely different kind of question that we don't have.
Because there are in mathematics, you're probably familiar with, different kinds of logics.
Yes.
And they're interesting mathematically. People study these logics. There's multivariate logic where it's not just true or false. It can be somewhere in between. There's a subject called quantum logic, which in some sense is modeled on quantum mechanics, where it's not just the particles here or over here, but it's some quantum mechanical mixture of the two. So is it conceivable that one of those or some other kind of logic would yield a kind of engagement with the universe that's utterly distinct from ours?
Well, it's sometimes suggested that the way in which we think, which is not the way quantum theorists think, the way people think, ordinary people think, is dictated by what's the necessary kind of logic that you need in order to survive on the African plains.
Yes.
And so when you're a medium-sized object hunting other medium-sized objects and moving at medium speeds, then you need a different kind of logic than if somehow you could imagine that we were shrunk to the quantum level, we would have a different kind of logic.
Yeah, right. Now you can well imagine that some very forward-thinking one of our remote ancestors who was out there in the savannah and actually thinking about quantum mechanics got eaten, right? So that's why it takes so much dedicated effort for us to figure out these quantum laws, because it's not built into our evolutionary structure. It didn't have any survival value. Presumably that's a reasonable way of thinking about it.
Yes, I mean, that's kind of what I meant, but not quite in those terms. I'm curious to ask an advanced theoretical physicist, which is, I don't often get that opportunity, but the weirdness, the sheer utter mind-numbing weirdness of quantum theory. Are you one of those physicists who, as it were, takes that in your stride and says, well, I can't conceptualize it, but the mathematics works, and so and the predictions that it produces are verified by experiment, and so in some sense it's got to be true? Or do you lie awake at night wishing you could understand, or perhaps you do feel you understand it
Well, I don't feel I understand it in the same way that I understand tables and chairs in a classical experiential perspective. And I do wish that I had quantum mechanical reasoning in my bones. I think I would engage with the universe in a radically different and quite wonderful way. I mean, look, we all know if I won't do it, but if I took this and I tossed it to you, you'd put out your hand and you'd catch it, which is an amazing thing because you didn't do the Newtonian calculation of the trajectory of the bottle. You just sort of felt it in your bones and you put your hand there and you catch it. So it's so mundane, but it's so wondrous that we're able to do it, and it just shows the power of imbibing the rules that are relevant on the scale at which survival takes place. And I wish I had that same quality when it came to an electron in the hydrogen atom, that I could just sort of feel the s orbital, and I could feel, the p orbital, like be in my bones, right? So if you ask me some question about the hydrogen atom, I wouldn't have to go calculate. I would just sort of be able to do what you did when you put out your arm and catch the bottle. So I don't have that. I wish that I did. At the same time, I certainly do use the mathematics to gain a confidence with the ideas. You ask me a question and it doesn't, send me scurrying for cover because I'm like, okay, I don't know really fully how to think about that, but I know how to set it up. I know how to solve the equation. I know how to interpret the mathematics because it's been going on for 80, 90 years. And that gives me at least some semblance that I know what's going on. But it isn't in the same intuitive, deep intuitive way. And that is a strange way to live, right? You live, as a physicist, your career, whatever, 30, 40, 50 years. And most of the time, you kind of don't really know what's going on.
I mean, do your colleagues, do any of your colleagues claim to have built into their bones, so to speak? Or do they all accept pretty much what you've said?
I don't know that I've ever heard anybody really say that. Well, actually, no, there is one. He came over to dinner. My wife is here somewhere. Tracy, remember Andy Strominger came over to our apartment, a Harvard physicist, and he was really angry at me for saying what I just said in public. He saw it in some version of this in some conversation, and he said, "You're giving the wrong impression of quantum mechanics. We fully understand it." And I was like, Andy, what do you really mean by that? But what he meant by that was, we have the equations, we have the math, we do the calculations.
Which is just what you said anyway.
Yeah.
Yes.
So I don't know that he would say that he has it. I'll have to add, I believe that he did not say that he had that deep intuitive understanding. Yes. But most people who think deeply about quantum mechanics even say that it's an incomplete subject as currently formulated. We do not know how to go from the fuzzy probabilistic mixtures of the reality that the math is telling us about. The electron is 50% here and 50% there and is in some sort of fuzzy mixture of the two. But yet when we measure the position of the electron, we always find it here, we always find it there. So somehow a transition happens from the fuzzy probabilistic reality to the single definite reality of common experience. And we don't have an equation for that. We just say it happens, or I should say people have proposed equations for it, but we have no idea if they're right.
Well, Schrödinger ridiculed the Copenhagen interpretation with his cat, his famous cat thought experiment. I'm aware that there are others who talk about the many worlds interpretation, who will say in terms of Schrödinger's cat, there are worlds in which the cat is alive and there are other worlds in which the cat is dead. that seems to me to be, although a hideously unparsimonious way of looking at things,
Yeah.
nevertheless, it's not totally ridiculous the way the Copenhagen interpretation.
Right, yeah. So just quickly, so the Copenhagen interpretation just says, hey, we don't understand the process, but here's an algorithm, here's a procedure. Follow the procedure, or as it's usually described, shut up and calculate, right? That's the summary of the Copenhagen approach. But that's not a theory of physics. Right, that's a set of instructions.
But I thought, in terms of the cat satire, so to speak, the Copenhagen interpretation would say the cat is neither alive nor dead until you open the box. So that's what I'm saying. Yeah. The algorithm is open the box, and at that moment, one of the two happens. Yes. How does it happen? I don't know, but it happens. We see it happen. Now, that's a little bit of a cartoon description. There have been more refined versions of this story called decoherence that have been developed over the decades. So it's not like it's stagnant, but it's not really a theory. It's just a set of rules. But let me just quickly add the one point that you did make about the many worlds being unparsimonious. And you really need to bring the right barometer, the right yardstick. Many worlds would be that there are lots of worlds in which the cat is alive and other worlds in which the cat is dead. And
that's right. So the many worlds basically says if quantum mechanics says that this can happen and this can happen and that can happen with some probabilities, then actually all three do happen. They all happen in their own separate world. Yes. So every outcome allowed by quantum physics takes place. Now that sounds incredibly uneconomical, right? The world is just becoming, the landscape of reality is becoming larger and larger with all these distinct realities allowed by the unfolding of quantum mechanics. But here's the point. It is the most parsimonious theory when you look at the mathematics.
Yes.
So the equation is pristine and sharp, and if you stare at that equation long enough, this is where the equation takes your thinking. If you just literally look at the symbols and say, what are those symbols telling me? Whereas all the other approaches add in other equations, other ideas, baggage, and that sort. So if you use the yardstick of the number of universes, out of control. Okay. If you use the yardstick of the mathematics, it is as simple as it can possibly be.
Well, I like that. That's very good. By the way, have you seen, there was a lovely New Yorker cartoon of a vet's waiting room, and the people were standing around with their dogs and cats and things. And the nurse is coming out and talking to a gentleman sitting there and saying, about your cat, Mr. Schrödinger, I have some good news and some bad news.
That's very nice. So I'm glad you asked about quantum mechanics, because it does give a sense of how our intuition can completely mislead us. The things that our intuition tells us are true or false may not even be describable in that language in the quantum world. It could be a mixture of both. And that is a fundamental layer of reality that our way of thinking about the world is not tuned into, not tapped into. If you're a trained quantum physicist, you can work it out, as we're describing, but intuitively it's just sort of not there. So I guess the question that comes from that, sort of relevant to other things that you famously talk about, what does that tell you about the nature of truth? I mean, you spend a lot of time, important time, going out into the world as an advocate for truth. And we all know what that means in sort of everyday scales, but if we can be a little bit more expansive in our thinking here, does this disjuncture between the truth at the level of fundamental physics and the truth at the level of intuition, excuse me for that spittle that just went halfway across the stage, does that distinction give you any pause?
Well, we came into this by talking about if Martians had a different kind of... I mean, to what extent is our conception of logic and truth governed by by what's necessary in order to survive on this planet? And if for some reason you need a different kind of logic to survive in Mars or Alpha Centauri or somewhere, would we have a different conception of truth? It's a dangerous time to be talking about this with fake truth and post-truth. And I think of myself as a naive realist. I mean, I think there is such a thing as truth. But quantum weirdness does worry me. But I'd like to think that although our view of the world is no doubt shaped by the need to survive in, as I said, in Africa, hunting buffaloes and things, I think I want to say there is such a thing as objective truth. I mean, I hate the idea which we hear from some academic circles that, I don't know, truth is a social construct and that there's no...
Well, I obviously I would agree that when it comes to the fact of the matter about the electron's magnetic dipole moment, right? That's a number that quantum mechanics predicts. We go out and measure it. They agree digit by digit by digit, 9, 10 digits down the road. And that does feel like it qualifies as truth in some way, or close, extremely close approximation of truth. But when we go to sort of higher levels, I guess I feel worried about scientists going out into the world. And you're right, it's a very curious time because, you know, we're meant to be out there proclaiming the facts about the world and the facts about the matter and the truth of the world. But with my experience in realms that are so different from the truth that we normally talk about in everyday life, it gives me some pause. Mm-hmm. Can you make me feel better about that a little bit?
No, because I live in a more naive. I mean, I live in a simpler world, and objective truth is something that we all live within our everyday lives, and that's the world in which we evolved, and so I don't have that difficulty. I'm just kind of aware. I mean, I have difficulty not just in the quantum field. I mean, there are other parts of physics which upset me as well. Well, in cosmology.
I'm happy to help if I can.
Cosmology, for example.
Yes.
I read that the Big Bang, that at the moment of the Big Bang, everything was compressed not just into a small volume, but into an infinitely small volume. I mean, that worries me.
Yeah.
I mean, I'm aware that a solid object like a table or a rock is mostly empty space, but nevertheless, if you were to compress it and get rid of all the space between nuclei, it would not just be the size of a proton. I mean, it would still be a fairly substantial chunk of stuff.
In fact, you can calculate. I once did a small calculation that if you were to take every person that's ever lived on planet Earth and remove the space between the electron and the nucleus and all of their atoms, then the remaining particles without that space would fit inside of a baseball.
But a baseball is a pretty big thing.
No, that's my point. I'm agreeing with you.
I mean, that is an astonishing calculation, by the way. I mean, it really is. Is that really right?
It's really right, yeah. And I have the baseball right here to prove it. No, but
okay.
But actually, I'm agreeing with you.
Yes.
You know, and so we have exactly the same worry that our equations, Einstein's general theory of relativity, are the equations that we use here. Those equations actually break down at time zero. Time zero is when everything would be crushed to this infinitesimally small size, and the equations themselves break down, which means that we don't really know what's happening at time zero, which is why, for instance, we've developed ideas that have tried to go beyond Einstein's equations, really to answer that very question. That question can be viewed as the motivation for a theory like string theory or other attempts to put quantum mechanics and gravity together to try to resolve that puzzle. We've not yet resolved it yet, but I will say one thing that is often misunderstood. So today, we don't know whether the universe is finite or infinite, right? In fact, Einstein once famously said there are only two things that might be infinite: space and human stupidity.
Yes.
And he said he wasn't sure about space, you know. And we're still not sure about space. But if space does go on infinitely far, then as you go further and further back, yes, it shrinks. But, you know, if you take infinity and you divide it by 2, what do you get? Infinity. Take infinity divided by 10, what do you get? Infinity. So things in the universe get closer and closer together, but the grand expanse of reality at time zero at the Big Bang would not be infinitesimal. It would be infinitely big, but it would have infinite density. So the idea of a little tiny dot from which the entire, not the observable universe, but the entire universe emerges, that could well be the wrong picture.
Well, but I don't know why you make it so difficult for yourself, because you, well, in the following sense, Hubble's law, and you reverse the process in it.
Yes.
I mean,
yes.
I can see, you crunch it down to something a bit bigger than a baseball.
Yeah.
Why go to something infinitely small?
Good. You could imagine running the film in reverse, the cosmic film in reverse, and you simply stop it a couple frames before time zero. You say, let's just stop it right here, and we'll go forward in our explanations from that starting point. We're really goddamn ambitious as physicists, right? We want to go. We really want to go to time zero. We really, and so it will feel to us as though we have left out the essential quality of cosmology. If we have to sort of by hand say, oh, stop the film, we don't know what's going on, and go further from there.
But why, when you get to time zero, does it have to be infinitely small? Why shouldn't it be
it may not, good.
the size of a cannonball? Or
if our mathematics told us that, then indeed.
So the mathematics tells you...
So maybe I didn't say it clearly before, but in Einstein's general theory of relativity, when you metaphorically wind the cosmic film further and further back, imagine the universe is finite in size, so we don't have to worry about the infinity, then indeed it goes right down to zero size. The radius of the universe goes right down to zero. And if somehow you could correct Einstein's equations, which we hope maybe string theory will do, so that with the correction, when you wind the film back to zero, the universe does not have zero size, but it's a little tiny nugget, like a baseball or some smaller entity, then that would be a very satisfying cosmology to start from that, from that point
forward. But the mathematics doesn't let you. Okay, we've come to string theory now, I often hear the criticism of string theory is devoid of evidence, and
really?
So, Mr. String Theory,
I've heard that too. Taking the taxi down to dinner, the taxi guy was all about string theory, no evidence. What are you guys doing? Rational science, reason. I just sort of cowered in the back and paid my bill and left. But so what's the real situation is the following. So we have a real issue on our hands, a theoretical issue of putting gravity and quantum mechanics into one consistent theoretical structure. Einstein's general theory of relativity does a fantastic job for gravity, makes predictions, and they're confirmed to high accuracy. Same for quantum mechanics as applied to the small domain. The problem is you try to put these two theories together, and each claims that the other is wrong. They shoot each other in the foot, and it doesn't work. So right there you see that you've got to make progress on making these theories harmonious, because they both are at work in the universe, and the universe makes sense, so the mathematics has to make sense. Now, we have, finally, Einstein was in some sense looking for this theory, but he wasn't really thinking about it in quantum terms, but the unified theory is what he pursued for 30 years. So we have this unified theory in hand, and then the question is, how do you know whether it's right or whether it's wrong? And now we come to the issue of predictions and evidence, and here's the thing. We can use the mathematics to make predictions. The predictions, unfortunately, are extraordinarily difficult for us to test. If we had a sufficiently large particle collider, then the collision of particles within the context of string theory would make a prediction that that collider could test. Now, how big would that collider need to be? Well, people have done estimates, and it would probably need to be the size of the galaxy. Now, here's the thing. The cost of an accelerator goes like the square of its energy, and if you're talking about a collider of that size, it's hard to get funding, So that's what it all comes down to. But my point is a serious one.
Yeah, I get it.
If this theory was not able to make contact with reality, you really think physicists would spend time on it? I mean, I think we go around once, and I don't want to waste my time on something that has no chance of ever making contact with reality, but it's hard. Now, in lieu of being able to build a collider the size of the galaxy, you try to find indirect tests, clever tests that might somehow be extracted from the theory, and we had hoped one such test would be confirmed at the Large Hadron Collider, which is a collection of particles that naturally come out of string theory. They're called supersymmetric particles. The name doesn't really matter, but these are particles that no one has ever seen. And the hope was that the Large Hadron Collider slammed protons against protons. You'd produce these particles in the debris, and that would be a nice piece of circumstantial evidence in favor of the theory. The fact of the matter is, those particles have not yet been produced. They may be produced shortly, which would be a triumph, circumstantial, but still a triumph for these ideas. Or it could be that the machine is just not sufficiently energetic to produce them. So it's not so much that the theory doesn't make any predictions, it's that it's very hard to test a theory, and this will be true of any approach to put gravity and quantum mechanics together because, yeah, I see you over there. I'm ignoring you, but I see you. It's going to be true of any approach to unify gravity and quantum mechanics.
I get that completely, but it's one thing to say it is in principle meaningless because there is no test, but to say that it is testable, but not in practice, not feasibly, whether under existing.
Yeah, and I think that's a fundamental distinction that gets lost, and I think it's a vital one.
Well, yes, and it's silly to lose that distinction. It's a perfectly good distinction.
Yeah. So can I go back to one line of discussion that we were pursuing a little bit before?
Yes.
The physics. Because I still have the following question, which is. Do you mind if we talk about God for half a second? I made a joke at the front, but do you mind if we talk?
Okay,
are you just so tired of talking about that?
Yeah, fine.
That's all right with you? Good, okay. Because we've had a conversation on occasion on this subject, and there's a lot we agree on, but there's some stuff that we don't agree on. And just as I feel like we made progress on string theory and evidence right now, I'd love it if like you could convince me to see the world differently. I would love to leave tonight. That would be a wonderful outcome of this evening. And if I could do the same for you, well, I'm not going to succeed, but that would be a wonderful goal too. So here's my question. I hear you say that you would like to, and stop me if I'm saying things imprecisely, that you would like to rid the world of religion. Is that too strong?
That's not too strong.
Okay, good. All right, good. All right, good. And so when you say that, here's my question. Are you saying that the structure and the history of religion is something that you just want to get rid of? Or are you saying that you want to get rid of what some people do in the name of religion? Do you make that distinction? Is that one that's relevant?
I certainly want to get rid of... Well, I see virtue in the effect that religion has had on human culture. I mean, I see virtue in music and art and things like that. But if we think of religion as providing an alternative idea for how the universe came into existence, how life came into existence, that kind of thing, then as a scientist I want to get rid of it. I mean...
Which I agree with.
Okay. Well, what part do you not want to get rid of?
Yeah, good. So, well, let me just give you an example, and you tell me where you come down on. Maybe that's the most straightforward way of doing it. So, in Jewish, I'm Jewish, maybe a few others in the audience. Thank you. So not all, of course, but many Jews here in New York view their religion in the following way. They're willing to cherry pick it for the parts that enrich their lives. They're willing to throw away the parts that are archaic and just have no place, in the modern world. They're willing to view it as almost poetry, almost as fiction literature, with the one difference being that it connects them to a long lineage that makes them feel part of a larger narrative. Is there something that you don't like about what I just said?
Oh, I get that totally. I mean, I have no problem with that.
No problem with that?
No. Because, I mean, you have a heritage, you have ancestors, you have literature, you have... I mean, it's the same as I feel, no doubt you feel too, a connection with Shakespeare. I mean,
right.
You know, I don't have any problem with saying I have a Christian heritage, a Jewish heritage. In the case of a Jewish heritage, you have an even stronger reason, which is the persecution of Jews,
right.
Which has happened through the centuries, and perhaps most notably in the 20th century, but earlier centuries too. This is a very powerful reason for a kind of loyalty to a tradition. Where I part company with it, as you do, is in where it makes claims about the universe and the nature of life and that kind of thing.
So when you say, just for my own clarity, when you say that when you agreed, and everyone sort of cheered, which is sort of fun, that you wanted to rid the world of religion, I wouldn't have thought that this would then be your reaction to my description.
Well, I suppose by religion I meant the scientific falsehood of religion. I did not mean tradition because there are in the Jewish tradition, there are all sorts of other traditions, tradition in literature, tradition in art.
Right.
I don't want to get rid of that.
So then I wonder about the following. So religion as as a word, a few 500 years old or so. It's not one that really goes back to archaic times. So, and there are some who have thought through the history of religious development and have indicated that the use of religion in the ways that you find utterly unacceptable is relatively recent, a relatively recent development. So if you take this structure that, go back a handful of thousand years, wherever you sort of want to, view its origins, 1500, 2000 BC, something of that sort, let's just say, does it not feel that you're focusing so intently on the last part of the development of that structure in a way that, at least as I've heard it, and it's different from hearing it tonight, which is very interesting for me, wipes it all out by virtue of what's happening now?
I'm skeptical of the suggestion that the scientific falsehood part of religion is recent.
I'm sorry, what?
That the scientific falsehood part of religion is recent. I'm aware that there are people who say that.
Yeah.
And I think they're wrong. I mean, I just think if you go back to the Old Testament, it would just be nonsense to say that the characters in Abraham and David and Moses and people were not interested in the scientific, quasi-scientific aspects of it. Of course they were. I mean, they were obsessed with it. They believed that there was a person called Yahweh who made the world and who actually intervened the whole time, who wrought miracles and things like that. I think it's Karen Armstrong who's made the case that the scientific part is recent. I just think that's not historically accurate.
So, but if one takes this metaphorical approach, as I was sort of describing it in that particular case, well, let me actually frame it somewhat differently. So, to what extent are you okay with, I don't know how else to say it, but irrational ideas? Can I just give you an example again? I don't know, about 3 weeks ago, I live uptown, and my mother lives over here, 81st Street. She's in her 90s, and I called. She's always home. She doesn't really go out without me. I called the answer machine picked up. She didn't answer. I called again. She didn't answer. I'm starting to like really freak out. So I get in the taxi cab, and I'm racing down to 81st Street, and I'm telling you, in that taxi cab, I was praying to God that she would be okay. And I'm praying to God, and I know that I do not think there is a God, okay? This is a totally irrational thing that I'm doing. Let me just quickly say, if you're there, I'm sorry, all right? If you're, I just got to hedge my bets, it's a conversation here. I'm just sort of saying how I feel. But I'm like really praying, and when I got there and everything ultimately was fine, it felt like, a small miracle to me. Now, I don't believe in miracles. I believe that we're all bags of particles governed by the laws of physics, and there's nothing else besides that. But at the same time, I find it useful to hold these irrational ideas in mind at certain moments, and I don't give a shit that I do.
Yeah, I get that. I mean, I think I'll make a similar confession. I would hesitate to spend the night in a notoriously haunted house. The faintest.
Oh, this is a good night, man. That is so.
But I mean, we're both being irrational, and that is a sin.
I agree. All right, I'm being waved at to open the discussion for audience questions. I can't see who's out there. I don't know who has a microphone, but whoever
We need
does,
the lights
feel free
up. Can we have the lights up, please, in the auditorium? That's not in the
not so much on us. Yeah, good, perfect.
That's not perfect. It's
Oh, is it in your eyes?
Yeah. I can just about dimly see people now.
Yeah, whoever has a mic, just jump right in.
Good evening, and thank you for a wonderful, wonderful night. I guess my question is, how do you dovetail rationality into the social and political dialogue that's going on in not just the United States, but in the world today? How do you combat irrationality with rationality at an emotional level, such that it's kind of
So the question is, did you hear it?
I did hear it. I was hoping you'd answer it.
Yeah. I can take a crack, and then you can sort of, clean up and finish it up for me.
I mean, we live in a time when rationality and truth are not respected in corridors of power. How do you reconcile? You don't reconcile them. What you do is you get out and vote the bugger out.
But I would add one quick thing on that. It's virtually impossible, I've found, to have a conversation with somebody who's not going to play by the same rules. And so it's virtually impossible to use rationality to convince someone who's looking at the world and describing things in an irrational manner. And I think we once discussed this, if I'm not mistaken, but I saw a video of yours once when you had a long conversation with a woman and trying to convince her about the archaeological record, right? And I sat there and I felt for you, because I have had those conversations with people about, the Big Bang and things of that sort. But it was clear that you were never going to make headway in that conversation. So you stayed with it, which is great, but that approach probably is ineffective,
yeah,
right?
she was a hopeless case. I know who you mean. Her name is Wendy Wright, and she clearly was not listening, and you're right, it was a totally lost cause. But remember, this was a television program, so although I was talking to her,
right,
it's irrelevant whether I could convince her. I clearly couldn't, but there would have been lots of people watching that television program.
That's true. Yeah.
Who would have been influenced by it and recognizing that she was being completely irrational. And so I don't buy the argument of it, which I've heard often, that because you cannot convince the idiot you're talking to, that means that you should simply give up. I mean,
right. Right. Yeah, I guess the quick question, but we have others. Would there be another strategy? And I don't know what the answer to that question is. And there are one or two questions from the audience still. So I think your side.
Sure. So going back to the idea of string theory, when you guys were talking about how to actually combine the two formats of math, I guess.
Yes.
Since we are the ones that actually created math to begin with, is it possible that what we use is fundamentally flawed to describe what you're attempting to do?
Totally, it's totally possible. I mean, I've had thoughts, I don't know, nightmares that when we have these conversations with the alien intelligence that we ultimately talk to, they'll come down and say, "Show us, guys, what have you done?" And figuring out the universe. We pull out general relativity, quantum mechanics. We open it up, and they just sort of look, math. We tried that. It takes you part of the way, but no, you'll never get anywhere with mathematics, And the problem is, when I then try to imagine what it is that they would substitute for mathematics, I don't have the creative imagination to think of anything that isn't ultimately isomorphic to math. Math just with some different formulation that we could map onto mathematics that we currently use. So yes, it could be that we have a limited set of tools based on the limited thing inside of our head that's taken us so far, but maybe it will not take us to the end.
Thank you.
So when I end up having discussions about science and religion to a surprisingly frequent extent, I end up encountering the viewpoint that science and religion are actually one and the same thought process, that science is a form of religion in one way or another. And I try to debate that in a number of ways, but I would be interested to hear what you would have to say to someone who says, well, science really isn't any different from religion in the first place.
Well, I'll give a real quick one, and maybe Richard will follow up. There are similarities, there are radical differences, and the most radical of all is show me how to use any religious text. I don't care, pick any one that you want. Show me how to use that to calculate the spectrum of helium. Right? So there are qualities of the world that we understand rigorously by virtue of the scientific structure. It is mathematics that makes predictions that we can go out and test, and moreover, if we test a prediction and it's wrong, we throw the thing away because we are incrementally moving toward truth, and that's quite different. And let me just quickly also add to that, just so you know that I'm not just spouting hot air. I really will put my money where my mouth is. I would be thrilled if tomorrow string theory was ruled out. I've worked on it since 1985, okay? I had black hair when I started, okay? But I'm not invested in it. I'm invested in truth or getting closer to truth. And this is the way that we can move toward truth.
I have nothing to add to that. I mean, I think it's absolutely right. And there's a huge difference. And the difference is evidence. In massive, massive, massive quantities of evidence. And in the case of religion, there is absolutely none whatsoever.
Given the singularity at the beginning of the universe, the Big Bang, and the evidence that particles are entangled,
yes,
that if that implies that all particles are thereby entangled with each other, does that intuitively have any implications for consciousness theory?
It's a good question. Since we don't really understand consciousness as we were describing here, it's a little hard for me to give you a complete answer to that. But I will say the following. It is the case that when particles interact with each other, they do acquire this very strange quantum mechanical quality called entanglement. Einstein, again, was a key figure in figuring out entanglement, as you no doubt know, but just so that we're all clear, if two particles are entangled, one could be over here, one could be over here, they could be on opposite sides of the country, opposite sides of the universe. You measure this particle and somehow it instantaneously affects the particle over there. That's weird, right? Einstein called it spooky action at a distance, right? Now, when you have all these particles interacting near the Big Bang, they do all become entangled, but the thing is, the greater the number of particles, the more dilute the entanglement becomes. And it can be diluted to such a degree that to some extent it doesn't really play the kind of fundamental role that it would with just two particles in a pristine environment that you set up to be maximally entangled. So while in some sense everything is connected to everything else, and maybe you want to think that consciousness therefore is sort of connected to the world through some quantum entanglement with our brains, the degree of entanglement is just so fantastically tiny that it's hard to imagine that that's how things will turn out.
Richard, anything?
Obviously not.
Thank you.
I'm just fascinated.
Thank you very much for both coming out and the lively discussion. I grew up in New York City, and I had a Jewish earth science teacher, but and so I didn't have the conflict between religion and science that Mr. Dawkins grows up with. And he just pointed out, if you believe the world was created in 6 days, how long would a day have been by that metaphorical understanding? So I was very grateful for my public school education. But my question.
Hey, I went to PS 87, IS 44, right down the street, so I'm with you.
My question is entangled with the previous one. The double-slit experiment in quantum physics implies that an electron will behave as a wave when it is not being observed, but returns to acting like a particle when we try to observe it, judging by the interference pattern it produces. This implies that the universe we live in is conscious. Without personifying this intelligence, would you agree, Mr. Dawkins, that quantum physics implies that our universe is conscious?
No. I mean,
Thank you.
Of course it doesn't imply that. It's nothing to do with it. It's deeply mysterious, but there are different ways of being mysterious. Just because they're both mysterious, it doesn't mean they're the same thing.
Yeah, there can be an error in thinking that often tries to imagine that consciousness plays a critical role in causing the fuzziness of the quantum world to resolve into definite reality, such as in the experiment that you described so well. But there's no evidence that consciousness is a vital part of that story. We believe, there were people in the 30s and 40s who put this idea forward, and it's very hard to rule it out, just like it's hard to rule out many things in the world, because we always bring consciousness to bear on any data that we look at, that we become aware of, that we can speak of. Consciousness is part of it. You could say, therefore, consciousness was part of ensuring that reality arose. But as far as we know, it doesn't need to be consciousness that brings a definite reality. It doesn't need a physicist with a PhD. It could be a mouse could do it. It could be a dust mote that could do it. It's any kind of interaction. It could be a photon in the microwave background radiation that bangs into the electron, and that forces it to snap to attention. So I don't see any direct role for consciousness, but who knows? We could be wrong.
Good evening, gentlemen. Thank you. One of the tangents we went down tonight was exploring the concept of extraterrestrial life or life outside the galaxy. So from Richard's point of view, you said we're a sample size of one. So all our concepts of what one may be is what we see before us, regardless of our imagination. And when you look at Hollywood and you look at aliens, they're sort of humanoid. And my thinking is any superior race has to be sort of like us, because we got to be able to make it. I can't see something with tentacles making a watch. So are you limited to what you believe a race may be outside of our existence because we're human and we have no other concept to measure against?
Science fiction writers are often criticized for lack of imagination and making them sort of humanoid but with 3 eyes, or some minor difference like that. There are biologists, Simon Conway Morris at Cambridge University is one, who actually thinks that the likelihood is that life would produce humanoids, and he goes, I think, too far, but he does make the point that convergent evolution is very powerful, and we have spectacular examples in the animal kingdom of different radically unrelated animals converging on the same design, because that's a very good way to be. You're probably familiar with, well, for example, Australian mammals, the marsupial fauna of Australia, produced a range of mammals which were niche for niche convergent upon the mammals in Asia and independently in South America. So he deploys the power of convergent evolution to suggest that if there is life elsewhere in the universe, quite probably it will look pretty much like us. I don't think I go along with that quite, but the point has been made. We talked a bit earlier about different kinds of life, whether it has to be carbon-based, that kind of thing. And I think it's an open question, and I think we can get a sort of handle on the question by looking at the animal kingdom and looking at the different things that have evolved in the animal kingdom, both divergent and convergent. But I think it's an open question, and I would, as I said before, I would love to come across a second sample of life.
I'll look around outside the parking lot.
I didn't hear that.
I didn't hear it either, but it was definitely funny.
Thank you.
Hi. You guys have talked a lot about T0, what happened after that. I don't think there's been a lot of talk about what happened, or not what happened, at T0. What happened at T0, what created it? Isn't that, and the universe happened, 14 billion years later, we have life, so everything was so precise. Does that imply some kind of God, watchmaker, or something? I mean, could you delve into more what you think about what happened before that instant at the Big Bang, not everything after?
Well, I'll start with the Big Bang, and then Richard maybe take it into the biological domain. But the question you're asking is, why is there something rather than nothing? And it is the key question, and it's one that we really have absolutely no idea how to answer. And I think we're all upfront about that. But once we allow for stuff to exist, space, time, matter, in some sense the laws of physics, with that minimal architecture, we can then run things forward. And as far as we know, we don't need anybody from the outside tinkering with things in order to get things where they currently are. So could you say that some God created it and then stood back? Of course, and this has long been said, and there's very little that we can ever say to refute that. The point of the matter, though, is it's not very interesting. It may be true, it ain't interesting. Why? Because you're just replacing one mysterious collection of words with another word, which to me holds as much mystery. So from the standpoint of explaining science, I don't find that it takes us anywhere forward. From the standpoint of understanding the rich structure of human heritage and our ongoing attempt to figure out who we are and how we fit into the cosmos, I do find there's a lot of value in that way of thinking about the world. But I don't find any value in terms of trying to find scientific explanatory power.
I think it's worse than that. I think it's worse than just not interesting. Because the point is that although it's very difficult to know what happened at the beginning and where the laws of physics come from, where the physical constants come from, what we can say is that it is relatively easier to understand how simple things came into existence than complex things. And a God who thought it all up and created it, even a deistic God who didn't subsequently intervene, whatever else he, she, or it was like, they could not be simple. I mean, if we're going to credit them with the brain power to devise the laws of physics and to set the physical constants to some optimal value, then they've got to be the kind of entity that requires explanation in its own right, of exactly the same kind of explanation as we in biology are used to providing in the theory of evolution. So it would have to be intelligent, in other words. And intelligence, creativity, inventiveness, qualities like that come late in the universe. We understand where they come from. They come from evolutionary processes. To suddenly smuggle in intelligence at the very beginning is to betray the entire scientific enterprise. So it's much worse than being uninteresting. It's positively anti-scientific.
So the one thing I would say is, well, since you got applause, I'll sort of agree with you. But my suspicion, or at least I raise as a possibility, the judgment of the complexity and intelligence required to give rise to the universe as we know it, I feel like you're coming at it from what we currently understand, which could well be completely misleading. There may be this incredibly simple starting point that a divine being could have invoked, and all of this might, by virtue of some deep symmetry in the structure that isn't even apparent, it's all simple from the standpoint of the ingredients and the laws, and it may be the... So I guess I slightly worry, even though I largely agree with you, I slightly worry about saying what would be required, because we don't know what would be required. That's what I mean by us not being able to figure it out.
But if it's simple, why call it God? I mean...
No, I agree. That's exactly the point that I made. It would be just replacing one word with another. But I guess I worry about the argument of trying to delineate the degree of intelligence and complexity required. I have no idea whether what you said is true in that regard.
But if it's just plain simplicity, just call it simplicity. What?
Yeah. So that I agree with, but it was the attributing a certain necessary level of complexity and intelligence that I find hard. But I agree with the larger point that we're just replacing one word with another. So you seem unsatisfied with that. I should have stopped when I convinced him of string theory. Okay, go ahead.
Yeah, if I was listening carefully enough earlier, I think it was said that the whole range of physics, from quantum mechanics to general relativity, you could understand the machine of the brain, but not consciousness. And two things occur to me about physics that aren't understood, and I'm wondering if you have any comment as whether consciousness might be fueled by dark energy or by the collapse of Schrodinger's multiplicity into the actual measurable singular.
So for dark energy, it's hard for me to see where there'd be any connection. You know, the amount of energy in dark energy is so feeble in any volume compatible with everyday experience that it's hard for you to imagine that energy making a significant difference. But when you come to the collapse of the wave function, the Schrodinger equation that you described, there are some very smart people who do draw a connection to consciousness, right? Roger Penrose is a very smart man. He was my graduate advisor at Oxford for 2 weeks. And he is convinced, by virtue of analysis that he's done for a decade and experiments that he's done with neuroscientists, that there is a connection between microtubules in the brain that can collapse the wave function, and he believes that that's the seat of consciousness. I've looked at it. I don't see it. I'm not convinced of it, but I can't say that I've studied it in great detail. So is that a possible link? I guess it conceivably could be.
Thank you.
I don't know if you...
I've tried to read Roger's book, but I must say I don't understand quantum theory enough to...
Right.
Hi. So my question, it's a fun question that I thought of because we were talking about a little bit how Lord Kelvin, though a really brilliant scientist, was astoundingly wrong about certain things about the universe and Earth. And so I wonder if we took two well-known scientists from your respective fields, let's say Einstein and Darwin, and we brought them to our time, what do you think that they would be the most astounded and amazed by with our current scientific understanding? And what do you think they would find the hardest to accept or be most skeptical about?
So I can do Einstein if you want, or do you want to see with Darwin?
I once had to do a television program in which a Japanese television company brought an actor dressed up as Darwin to visit me, and I was supposed to bring him up to date as to things that had happened since his death. It was an interesting experience because he was well made up. He had plenty of slap on, which kept on dropping off. I sort of bowed very low and said what an honor it was to meet him and things. And then I had to explain to him about modern genetics. And this would have been very surprising to him, very interesting, not so much surprising as revelatory to him, because in his own lifetime, not only did Lord Kelvin's estimate of time worry him, he was also worried by a man called Fleming Jenkin, who made the point that because of the prevailing genetics of Darwin and Jenkins' time, which was blending inheritance, they were aware that, of course, that animals inherit from both parents, but they thought of it as being a kind of mixture of the mother and father, almost like mixing two liquids. And Fleming Jenkin pointed out that if that were the case, offspring should be intermediate between the two parents. And if that were the case, then there would be a rapidly, natural selection would run out of variation on which to select. And this did worry Darwin. He shouldn't really have worried, because it was quite obviously not true that variation disappears. It's not the case that as the generations go by, animals become more and more grey and sort of uniform. They do retain their variation. But nobody understood why. And it wasn't, well, Mendel, who was a contemporary of Darwin, actually did discover why, but Darwin never knew about it. It wasn't rediscovered until after Darwin's death. So I had to explain Mendelian genetics to this actor posing as Darwin, and also DNA. And he did his part well. He said, "Yes, that's it." So I don't know whether that, I mean, I think that is one thing that would have, as I said, not quite surprised Darwin, but he would have felt, yes, everything clicks into place now. And I now, that was the one thing that Darwin got wrong. He got precious little wrong. I mean, if you read The Origin of Species, it is an amazingly prescient book. As Michael Gieselin said, he was working 100 years ahead of his time. Astonishing man. But genetics he did get wrong. And so that perhaps the answer.
Yeah, so quickly on the Einstein one, I think Einstein would be surprised that quantum mechanics is still with us effectively in the form that he detested. And he thought that advances would do an end run around quantum mechanics, and somehow all the weirdness would disappear with the deeper understanding, and it hasn't happened. I also think that, as we describe as we describe string theory and all the qualities of the theory, and I think you just say you guys are geniuses. Utter geniuses.
I have a question for Brian regarding mass. I understand from Einstein that a particle's mass increases with acceleration. At CERN, they take protons and accelerate them to very close to the speed of light, over 99.99% of the speed of light. My question is, what is the change in the mass of that particle from rest to the point of collision?
Multiply it by 1 over the square root of 1 minus v over c squared. V is the velocity, c is the speed of light.
Thank you. Thanks very much.
I didn't understand that answer at all. And so I have to write this, but I'm going to ask, hopefully, for a non-pessimistic answer to this question, which is, I'm a little puzzled by the disappointment in the search for extraterrestrial intelligent life, because it seems challenging by, or severely limited by, two elements. One is astrobiology, which seems to suggest that the combustible energy sources that would be, they suffocate the species that create sufficient advancement to support radio wave broadcasting. We're suffocating ourselves. And the other element that I find challenging in terms of evidence for extraterrestrial life is the time synchronization needed to collect a radio signal. The duration of a species that's broadcasting is probably short.
Yeah.
The universe, when I was growing up, we thought it was expanding. Now you guys have changed the rules again.
No, still expanding.
But it's accelerating.
Yeah,
it's
that's
accelerating.
good.
So in some period of time, we're only going to see our own galaxy. So you've got a dual-pronged problem of combustible energy suffocating us, or others, and getting the signals to synchronize. So why would we see
Yeah, no, I agree.
extraterrestrial life?
You're pointing out how unlikely these programs are to succeed. I mean, look, life on this planet began very early on in the history of this planet, but in that 4 billion year window, as you're saying, we've only been radio broadcasting, what, for the last 50, 75 years. So even if an extraterrestrial civilization was trying to find us, and they sort of knew where to look, it wouldn't just be a matter of pointing their scopes in the right direction. They'd have to be waiting for just the right interval of time. So I think you're pointing out how hard it is, and therefore perhaps not surprising that we haven't found any, if indeed life is commonplace throughout the universe. And the other thing is, look, you know, we now know of so many planets, right? That's one of the major changes in the last decade, right? There are so many planets out there. And if a fraction of them support life, right, there could be whatever. There could be, 100 million civilizations scattered throughout the galaxy, okay? But that's one per enormous number of stars. So it's still very sparse, even with 100 million civilizations out there. So it's hard to find.
And what about your take on astrobiology and the likelihood of a species suffocating itself? I'm curious to hear what Dawkins'
yes, I mean, there's
perspective on
a further source of pessimism would be that the interval of time between a civilization working out how to send radio waves and destroying itself by warfare of some sort. Yeah. It could be, I mean, there could be civilizations winking into existence here or there and then winking out again after a rather short time. I guess that's another aspect of your suffocating, I think.
So quickly, we're at 10 o'clock, but I think we started a little bit later. You guys okay to do another 5-10 minutes? Is that okay? Okay.
There seems to be a widespread idea in the culture that in order for life to be meaningful, we all eventually have to die. And I'm a little skeptical of that idea. It seems meretricious, like makes us feel better that there has to be some meaning. But if you imagine asking someone 50 years going by in their life, is your life still meaningful? Are you involved in useful projects? Are you advancing things? It seems like life could still be meaningful no matter how old you're getting. So I wonder what your thoughts are about the necessity of death for the meaning of life.
I'll let Richard
there is a pretty sound Darwinian reason why we die, which I can perhaps briefly explain. Genes mature at different, I mean, when I say mature, have their effect at various times during life, and most of them have an effect during early embryology, but then they have effects later and later and later. And if you imagine a gene that makes you die of, for example, cancer at the age of 10, and then another gene that makes you die at the age of 20, another gene that makes you die at the age of 30, 40, etc. The ones that make you die at the age of 10 are never going to get through into the next generation. The ones that make you die at the age of 20, a few of them will get through. Ones that make you die at the age of 30, quite a lot will get through, etc. And ones that make you die when you're 100 will certainly have got through by the time they kill you. So we are a kind of dustbin of late-acting lethal genes, or sub-lethal genes, which is why, from a Darwinian point of view, we die of old age. And there's a more sophisticated versions of that theory. But you seem to be talking rather less in a Darwinian way than in a sort of subjective way, saying, wouldn't it be nice if wouldn't life feel more meaningful, I think was the way you put it, if we didn't die?
No, I was challenging the idea that people spread that in order for life to be meaningful, we have to die. Like, people say life wouldn't be meaningful if we lived forever. And that just seems...
Well, I don't know who says that. I mean,
like Bernard Williams says that. I mean, there are philosophers who've thought this issue through and have make cogent arguments that all the things that give life meaning that we usually list, many of them would evaporate if we didn't die. Right? I mean, if those of you who, your abilities could always improve over time, well, if you have infinite time, you'll be able to achieve anything. So there'll be no real challenge, there'll be no sense of success. Those of you who your abilities will plateau and hit a limit, well, for eternity, you're going to be stuck. Right? That's not going to feel too good either, right? So these are nice, interesting thought experiments. It's hard to really know, but I guess from a flat-footed, straightforward perspective, I just wonder if you had the opportunity. Hey, Professor Dawkins, you've done so much for humanity. We're going to let you live forever. Would you choose that?
No, I maybe 200 years, but.
But at the end of the 200, they came back to you at the end of the 200 and said, your 200's up. Hey, you want a couple hundred more?
Tell you what, I think the only frightening thing about death really is eternity. And I'd rather spend eternity under a general anesthetic. Which is what's going to happen.
All right, so we only have time for 2 more questions.
I have a question for both of you. I'm curious if you think it's possible or even likely that the true nature of reality and physics could be something that's fundamentally just inaccessible to the human mind because of the way our brains are wired.
No, I had a NOVA program years ago on a book I wrote. And in one of the scenes, I'm at a blackboard lecturing to somebody who clearly is not getting because I'm getting frustrated. And ultimately the camera pans, and it's a Labrador retriever that I was, and it was misunderstood by many people. They thought we were trying to say the audience is like the dog. But that's not what it is. The point was, there are intelligent species that walk this planet that seem to have a limit to what they can understand, right? Dogs and cats are smart, but they seem not to understand the general theory of relativity, right? Every time I say that, I always think the dog's going, he thinks we don't understand relativity, stupid human, But barring that possibility, there are these smart beings that have a limit. Why would we be any different from that? That's the point. So exactly like you're saying, it could be the truth is right out here staring us in the face, but we just don't have the brain power to grab hold of it. And maybe we never will. Now, the optimistic way of saying it is, even with this limited brain power, look what we've been able to figure out, right? We can figure out laws that tell us how the universe evolved from a split second after the beginning. We're able to pry apart matter and understand its constituents. We understand how time elapses, how space expands, why stars shine. I mean, that's pretty great stuff. So maybe we have the brain power and it's just a matter of time. But nobody can say for sure.
One of my favorite science fiction stories is Fred Hoyle's The Black Cloud. Despite its obnoxious hero, it's probably modeled after the author, I should imagine. But at the end of the book, the humans are in touch with a superhuman intelligence. And the superhuman intelligence, the Black Cloud, communicates to them its knowledge of physics, and they can't take it. The human brain just burns up. And 2 really smart physicists die as a result of overheating of the brain. And so that I think is perfectly possible, that we are not capable of it. On the other hand, I agree with Brian. I'm amazed at the fact that a brain which was naturally selected on the African savannah to hunt and gather is capable of devising special general relativity, quantum theory, and it's astonishing what the human brain can do, given the much more limited tasks which it was required to do when it was being naturally selected. These are emergent properties. It's a wonderful testament to the power of emergence, and so maybe there isn't a limit, but I don't know one way or the other.
Thanks.
Hello. Do you think that modern physicists are worried enough or spending enough time on realism and ontology? And specifically, what do you think of Bohmian pilot waves?
That is exactly the question I'd hoping we'd end on. We just had a conference, for instance, at Columbia last week, where the focus was philosophers were involved, and some physicists have sort of described philosophers as having no role in physics. That's utterly ridiculous. These are folks who've thought hard about quantum physics, forcing us to really try to link up the mathematical symbols with real things in the world and to shake those dictionaries and make sure that they really work. And we're uncertain at the moment. So on the ontology side, people do think about it, but it's typically more in the philosophy side of things. And I do think that physicists could do more to advance that, that project. In terms of this Bohmian approach that you mentioned, this is a very interesting story that I'll just tell in 30 seconds. The approach to quantum mechanics that Richard was describing, the Copenhagen approach, that was really in some sense promulgated by some very convincing physicists in the 1920s, 1930s, and so forth. Niels Bohr being sort of the famous father of quantum mechanics. If the Bohmian approach had a champion of that magnitude and that level of respect, I think it would likely have been the dominant way that we would have thought about quantum mechanics. Why? In the Copenhagen approach, you have to give up making definite predictions. You can only make probabilistic predictions. That's hard to swallow, okay? But you also have to give up particles having definite trajectories. Particles no longer go along trajectories as in the Newtonian picture. In the Bohmian approach, yes, you also have to deal with probabilities, but particles do have definite trajectories. So you only have to sort of give up one thing in the Bohmian framework, and you have to give up two in the Copenhagen one. So I think people would have had an easier time and would have latched on to this way of thinking about things. People still push this theory forward. Whether or not it's actually right in the sense of it's the real description of the world, nobody knows. But it's a worthy contender in an arena where many are still competing to win out with the right way of thinking about quantum mechanics. And with that, thank you very much.
Let's give a big round of applause for Brian Greene and Richard Dawkins.
Thank you, sir. Terrific. That was well done. Thank you very much. Wonderful.
All right, you guys, thank you so much. Please join us in the lobby for a book signing. I think there's a few left to grab.
Sorry, can I just say?
Richard has something to say.
Is my mic still on? Okay. On the book signing, it's a very large audience, and out of courtesy to people at the end of the signing queue, we don't want to take too long at the beginning of the signing queue. And therefore, we cannot personalize, actually dedicate books to particular people, and also, please, no selfies.
All right, thank you guys so much. Remember to go to penguinphilosophy.com, check out our events that are coming up this month, and let art and science inspire. Good night.
At his eyes full of visions, he prostrate on the ground in his village, told of a monstrosity called capitalism. Said the food they grew would be shipped from the country, and they barely get by. Well, someone else got the money. Said the government helped these people out with the army. Problems that were never big would inflate alarmingly fast. But the people walked past, he thrashed on the grass. Nobody paid attention except the few who had a laugh. No mind could imagine such a change of scenery. The culture was strong and intact like the greenery. But not for long. To the planet at last, man. Revolution made it happen really fast. He said, how can we find supply for demand? Somebody suggest